Well, today what we're going to do is we're going to be talking about 11.2 and the chi-square test for independence. And for this test of independence, test for independence of chi-square is very, very similar to the test for homogeneity. All right. The only difference is that when you talk about homogeneity, we are talking about experiments. Okay, talking about an experiment where we usually have two samples and one variable. For independence, essentially we have one sample. It talks about an observational, I would probably say maybe an observational study that we're looking at with two variables. Okay, so we're taking one sample, we're dividing categories or different two variables, and we're trying to see if there's any association between them. Okay, Goff, of course, greatness to fifth is one sample, one variable, and going through with several different categories. Okay, all right, so what do we do here? Well, first off, if we're talking about independence, our null is there is not an association between A and B. And for the alternative is there is an association between A and B, wherever that case may be. All right, so let's try this out. And so I got this from Statsmedics. So thank you, Lindsay and Luke, for this wonderful example. And here we go. So is there an association between gender and preference of English or math class? Below is the data of a random sample, so one random sample of seniors here. So we have one sample. Do we have convincing evidence that gender and favorite class are associated? So we have two different categories, gender, all right, or two different variables, gender, variable 1, all right, and favorite class, variable 2, okay, variable 2. And so from here, we need to figure out what is that going to be. Now, if you recall, what does independent mean? That means if we have two events, A and B, the probability of A times the probability of B will equal the probability of A and B, okay? So essentially, if you want to write this out, probability of A, all right, is going to equal the probability of A and B happening divided by the probability of B, okay, which essentially is probability of A, all right, will equal the probability of A given B, okay? So essentially there is no difference between this probability and if B were to happen, the probability of A given B would be the same, all right? So there essentially is no association with them. All right, so from here, what we have is we're going to calculate, first off, we're given our information. So here is our observed value. So from our one sample, all right, one sample of seniors, all right, students, seniors, what we see is that we have a bunch of different females. We had 65 total females. We had 49 total males right there for a total of 114 students. We realized that females had 43 preferred English, 22 preferred math, and males 21, and then males 28, and so on and so forth. So how do we calculate this? Well, because this is very, very similar to we have two different variables and several different categories in there, we're going to perform this by doing the same thing that we did for homogeneity. And so we're going to take and find this expected values. We're going to find this, like for example, this one, we're going to take the total in this row, so 65 times, all right, English 64, all right, and divide that by 114. And so that's what we're going to do to calculate all these different values. So if you take 65 times 64, all right, divided by 114, all right, we can see we have a value of 36 point, and I'll just go 49. And we can do the same thing over here. All right, so for math, we're going to take 65. Okay, so for this one, we're going to have 65, all right, times 50, divided by 114. All right, so 65 times 50, all right, divided by 114. And we'll have about 28.51. Now, when you take those two numbers together, all right, 28.51, all right, plus 36.49, all right, what you should have is you should have the same total of 65 that we have here. And that makes sense. So we do the same thing for all the other ones. So we take 49, all right, times 64 divided by 114, and then we'll have 27.51. And we can do that. And you can fill up this table. And we have 49 times 50 divided by 114. All right, so we have 21.49. Again, we'll have 49. And then you know this is going to equal 114 here. And these add up to be 64. and 50. Okay, so we have our two different values that we have there. Okay, so we have our expected values. Now, do the data provide significant evidence that there's an association between gender and preference of English or math class? Well, first off, all right, we assume, just as we said before, there is not an association. So we're going to assume there is no association. All right, there is no association, all right, between gender and class preference. I'll just say that, and English, all right, versus math. Okay, we have that right there. Now, the other one is basically opposite. So there is, all right, so the alternative is that there is an association, all right, between gender and class preference. And that's what we have there. So we're going to do this to a significance level of 0.05, as they stated right there. And now let's continue through. So because we're looking for an association, okay, we're looking for association, or trying to figure out if there's any, if the errors are independent, all right, between there. So we name our procedure we're going to call is going to be the chi-square test for independence. We're going to check for conditions. Was there a random sample? Yes, there was a random sample of 114 seniors. So we got that. We can see that our expected counts, all right, are right there. The smallest one is, it counts smallest equals 21.42. All right, 21.42. And that is greater than or equal to 5. So all expected counts are, all right, larger, greater than equal to 5. All right, so we have that going for us. So we have all the conditions met, all right, in order to perform this chi-square test for independence. The next thing is now we want to show some work. All right, so in order to show our work, we need to figure out what our chi-squared statistic is. Okay, so in order to do this, we're going to go over here. We're going to say, okay, we have 43 and 22. All right, and we can just write those couple things out here. So we're going to take our observed values, 43, minus our other value over here, which is 36.49. All right, 36.49. And we're going to square that divided by the expected value of 36.49. And we'll say this, but that we'll keep on going, and we'll just take the last value. I'm just going to take this one, 28 minus our expected value of 21.42, square it, and divide it there, all right, by 21.42. We're now going to go to our calculator and just get all this information from our do process that we need. So if you take this, so you take out your calculator, and if you go over here, you can punch all the values in here. So you need to go to your matrices, if you recall. Make sure you go edit them, all right? We're going to have a 2x2 matrix, and you can see that I put my observed values in the first matrix A, and I also put the, all right, values over here. In the next one, if I go down here, I can edit, oops, the other B is going to be my other values. So from here, we're going to go, and we're going to go to stat, and we're going to test. And from this test right here, we're going to go up here, and we're going to find out what our, all right, C value is, or a chi-square test. Now, this is a chi-square test. Now, I goodness a fit, but a chi-square test. We're going to go to C. We're going to have observed as A. I expected I put in for B. Color is blue, and it doesn't matter. And now we're going to go to press to calculate. And press to calculate. And this is the information we have right there. Okay, so now grabbing that information, we can now do something with that information. So I found my chi-square test, okay, and my test statistic. By going right here, we realize that's going to equal 6.158. We know that this right here, starting at 0, a chi-square, all right, distribution, and we can write that, and I have a degrees of freedom of 1. Now, why do we have degrees of freedom of 1? Well, if you recall, our rows, which are 2, okay, 2 minus 1 times 2 minus 1. That's going to equal 1, and that's why our degrees of freedom are going to be 1. Okay, so our chi-squared statistic is going to be over here, and I'll just put that 6.158. And what we're doing is we're trying to figure out what is that probability. What is the probability that that will actually occur? So our test statistic we found out is 6.158. All right, our p-value, so the probability of getting a chi-squared value, assuming that the null is true, all right, a chi-square value of 6.158 or greater, all right, is going to equal 0.013. All right, 0.013. Now, what can we conclude? Well, from our information, just like we conclude everything else, all right, since, this is how I write it, since our 0.013 is less than 0.05, we reject the null. All right, we reject the null. We have convincing evidence. All right, evidence that there is an association, all right, between, all right, gender and class preference. All right, and the class preference is English, all right, versus math. Okay, and that's what we have there. And that's essentially what we found, okay, from here. So essentially we begin by saying that they are independent, but then we realize our alternative, if they're not independent, then our alternative will be, well, found convincing evidence that they are not independent. Okay, so, and that's what we have there. So, and there is an association between gender and class preference. Okay, so that will, having female, there is going to be a difference between what you pick. All right, looks like here's probably English compared to males, who they probably will pick will be something else different. And right there, they show a little bit more math. Okay, different than what we expect in our expected values right there. Okay, and that's what we have. So from that values, all right, from those different things, we can see there's a preference, and that's what we have there. So that's how we do independent. All right, chi-square test for independence. Well, hope this helps you out, and good luck and God bless in the rest of your problems.